tell us the story, how we got to know each other.
So it started about 4 years ago when we signed a research collaboration with MIT, with Daniela's group, on trusted AI, because that was really important to us. And that's been great, that's been a big success. And then about a year ago, we found out you guys were spinning off, so we joined that party, if you like, through an investment through Capgemini Ventures, and we've now got a global partnership. So it's been a long relationship we've had.
Yeah.
And it's great to see you at this stage, really.
Yes.
It's brilliant. It's brilliant.
So the first enterprise that we ever interacted with was Capgemini, because it was like through MIT connection, like we were doing research together, and then we got into more commercial aspects of things. So tell us a little bit about augmented engineering.
I think we need to click the slide, do we? Hold on.
Yes, we do. Beautiful.
Okay. So it's not what I was expecting. No, that's not what I was
This one.
That one. There you go, we'll go here. Ask me the question, it'll work.
Yeah, okay. So augmenting engineering.
Yes, so we talk about at Capgemini, and the reason we got involved with you guys is we think about, I'm a CTO for engineering, so I'm concerned about products, how people build products, whether they be aircraft, CT scanners, cars, etc., and how you build those products and how you put AI inside of those products. And we're convinced that AI is transforming both the way you build engineered products and also the products themselves, right? But we see it very much as an augmentation of that activity. It's not some kind of magic dust that you sprinkle on engineering and all your problems go away, which is some of the narrative that you almost get. So we tend to talk about augmented engineering in terms of using AI.
Tell us about when you look at AI applicability, to engineering projects. Tell us examples.
I think anyone involved in product engineering will know that it's dominated by two things, I think: correctness, okay, and constraints. So, if you're building an aircraft, if you're building a car or whatever it is, okay, a good guess is not really what you're after, okay? You actually want to know whether it's correct or not. So we've generally been looking at technologies around AI that help you solve that problem of correctness. And the other aspect is constraints, and those constraints are twofold, right? You've got product constraints, which you've touched on a lot today, things like memory footprint, real-time performance. You can't tow a server behind your car, right? And the other constraint actually is the process. People have mentioned regulation. A lot of our industries are dominated by standards and regulation, etc. So any technology that addresses the correctness question and helps us address the constraints, whether they be memory or regulation, okay? That's why the explainability is so important, is really important from an engineering viewpoint.
And how is Capgemini deploying AI for customers?
So I think we've got a slide, we'll try. There we go. Part of it, anyway. So one example that we've done, I could talk you through a couple of examples, and they use the different products that you've got. Okay. One example here is for a car handbook. This is for you've got an 800-page owner's manual if you buy a car these days, and no one reads it, and you need to be able to interact with that manual effectively. And an LLM is a really nice way to do that, but of course, from an automotive viewpoint, you're limited with the compute. Okay, you cannot assume that you've got connectivity. So we managed to deploy a really lovely owner's manual type interaction on just a conventional hardware that you would find in today's automobile. Okay, which is a really great demonstration of a practical application of LLMs when they're sized correctly. The other example that I think I'm really not.
Yeah. Now we're set.
Okay, hold on.
Ooh.
Whoa.
You should have gone.
That's the one I want.
Yeah,
That's the one I want. Hold on. This one. We did another one that we've done is a project around optimization of telecoms networks. Right. And if you know this, but you use a huge amount of energy and cost in mobile networks. And we've done a great project where we've been modeling switching antennas off, okay, in order to save energy and cost, which you can do at certain times. Okay, if the operational conditions allow, and we've been using your technology and we've been benchmarking it against other state-of-the-art deep learning technology, and basically it's more accurate. Okay, it more accurately predicts the number of users that you're going to have. It accurately predicts the packet loss that you're going to have. Okay, and that enables you, before you do take that decision to switch an antenna off, to know that it's not going to affect the quality service of the user, right? So we really see those a whole range of those kind of time series type problems as a real strength of your technology.
Amazing. I don't think we played the previous demo. Like, can we see it?
I don't.
I think, let me
maybe
try.
you can work in archives beyond.
Let me see. Okay, so this one. Let's go one back. Okay, I'm just gonna play. I'm gonna play one more time and one more time. There we go. All right, so you got the car manual over there, and a liquid model is actually offline. It's actually taking, information from that car manual. So you can imagine like uploading a massive amount of documents in there, right?
Finally, we'll show you the audio mode. In this mode, users can ask their questions using their voice. The speech is transcribed and automatically submitted. The AI responds by writing the answer and then reading it aloud. Watch the demonstration.
Okay, great.
And obviously, for a lot of clients, this ability to deploy an LLM like that in something, just the power of a normal PC is just, hugely valuable for a lot of our customers in a lot of different use cases. Yeah.
Looking into the future, where do you think AI is going? For you, for Capgemini.
Talking from an engineering viewpoint, I think what we see is what we would call hybrid AI is the real. When you look at it from an engineering domain, we think you've got to combine different kinds of AI technologies, but also with other types of engineering mathematical models, okay, that help you solve the correctness problem. And obviously, your technology helps with that, all right? And I think where you put that knowledge of physics, where you put that knowledge of the system, whether that's in the AI or it's in a different model of some description, I think will be interesting to see. But I really think it's going to be a hybrid approach of different kinds of model within the context of engineering.
Do you believe in small models or larger models?
Do I believe in small models or larger models? As an engineer, I would say that would depend on the context. Obviously, a small model is better by definition, but it depends on the quality metrics. Yeah. So for that, so I think it's horses for courses. I think it depends, but I definitely believe in models that are tuned to the specific problem that you're trying to solve.
Absolutely.
That may end up being big or small. It depends what the problem is you're trying to solve.
And reliability matters.
Reliability counts hugely.
Fantastic. Thank you so much for joining us.
Thank you very much.
Ladies and gentlemen.
Thank you.
Keith William.
Okay.